Hello everyone, in this video I want to talk about this binning process I've been going through for this memory. I have a lot of them going around the lab, currently sitting in different computers. So let's first go through the reason, which is straight here. So I'm binning these models and I'm editing their SPD profiles to improve performance in pre-built machines that have no access to memory timings in their BIOSes. So what I basically do here is testing each individual stick and then pairing together based on the performance statistics. I have been doing this spreadsheet here that has one tab for each module. Every module has been labeled with a different stick, like this one has an N on it, this one has an A, reversed A, and this one has written conservare on it, which is preserve, like conserve. They come from food labels. Well, this one has another E on the other side. Yeah, um, I've been testing them one by one. Then I group them based on their similar performance statistics, and then I write the SPD accordingly. For example, here I have some SPD that are already written with CL13, 14, 14, 34, and TFAW16, TRDS4, TRDL6. While on this side, I'm actually testing for TRD, RDL, and S at 4, both 4, but TRFC is 248. While on the left, it's here it is, it's 232. So I'm doing a lot of cross-testing this through different devices. Yeah, I then use SPD check to extract the SPD. Then I use DDR4 XMP editor to modify the SPD, and then I use SPD write, which is included in the SPD check file, to write them down. So now we have, for example, this profile that I wrote, 14, 14, 14, 34, TRFC 248, and you can see as RDL I set it to 5 actually, just to be on the safe side. This is the profile that is running in this machine, for example. I've been doing this like testing and also like moving the sticks inside machines to see what happens for a couple of months now, 3 months maybe. So one problem that I've encountered is that this machine, for example, sometimes fails training, and it fails training in 2 different ways. You can so you can actually have 3 different outputs with this machine. You can either get this machine to actually recognize the SPD and boot fine with all the timing set. You can then have a situation where the machine boots but doesn't use your timings, which is weird. I have no idea how that happens, but it apparently reverts to the Jdec specifications. And then you have the third situation where you actually have an error code for memory training, which is I think 3 beep, long beep, and this machine doesn't post. So I had to make a new profile for this, and I think one module maybe was failing training for the TRFC being too low, 232, or the TCL. I couldn't track it, so I actually increased both. I set TCL to 14 and the TRFC to 248, and this allowed this machine to boot reliably for the last 2 days. It took me a couple of trials and errors as the problem was arising after memory training, so I just figured it out after plugging the machine a couple of times. But yeah, the machine has been currently reading the profile right for a couple of days and been through a couple of reboots and now installing Windows from scratch as I'm finalizing the machine for delivery. And yeah, it's interesting. It's an interesting process. And let's get to the binning part. Sorry for this tablet has a glare screen, so reflective screen, so it's quite awful to read. But the most interesting thing about all of this is that we have different sticks getting different results at the same settings. So for example, the most common TRFC that will get best results for this sticks is 280. So most sticks will actually give their best results, their best average impact for 30 runs, I think, at 280 TRFC. So you can get them to boot maybe at 264, 272, but they would perform worse. But some of them, most of them actually run at an average of 180 score for impact, 180 average score for impact. But some of them at the same exact timings will have an average of 185. I didn't have any doing 183, so they were two different tiers of performance. One is 118 and the other is in 185. And some other sticks would actually get 185 and even 186 at lower TRFC. But like this one, the best one, I guess, that gets the lower TRFC, can actually get the best results at 156, but the best result is still 186. So it's not much better than the best sticks that run 280 can do. So it's very interesting. So that's why it took me so long to actually make this video, and it's still a very, very work in progress project for me. So there's some of them that would do 178 at 180, so they're the worst ones. It's interesting. It's very, very. It's a very convoluted process. It's very hard. To do all this testing, I've used the same machine, the Z390 UD board here from Gigabyte, and a very slimmed down installation of Windows, of course. That is an Windows X Lite with additional tuning and more disabled services like Windows Update to ensure the lowest memory usage. And yeah, it's interesting, and that's all I can say really. The performance improvements by doing this are in the order of 10% for a pre-built machine on Limpac, for example. More on the 20% for Pipeline, for example. So it's there. There's a performance improvement. Even I didn't actually test the same configuration with 4x4 sticks. These are 4 GB sticks. I bought 4 GB sticks because most of these machines will have 4 sticks, and of course, if you populate all of them, since you are actually tied to the memory controller, artificial limit and frequency, it's better to have more sticks. Because if you have less sticks in a normal system, you can reach higher frequencies if you have an unlocked CPU. But these systems are locked, so it's just better to have 4 sticks to populate all of them and get better parallelization. So that's why I bought 4 GB sticks. I bought all the sticks during the summer, back in July, way before this memory cost increase, this DDR cost craze went on. So I was kind of lucky with that. And yeah, the project is just taking some time because I do that on the free days, on Sundays. That's what today is. Yeah, I'm quite satisfied with the results so far. And what else can I say? Yeah, sometimes you can get pre-built machines with very good OEM sticks. For example, these two sticks that I'm testing on this Z490 ITX build, these are Micron 16 gigabit eDie, which is, yeah, here it is, 16 gigabit eDie, 16 nanometer, currently running at 3466 mega transfers. So this memory was actually sitting in a pre-built machine with an i7 7700, which is limited to 2400 mega transfers. So I was able to move a very awful memory kit on that machine with SPD tuned and get better results on the i7, and then take the sticks that are capable of very high frequency on this unlocked i9, which is a very good optimization for both parties, I would say. This is in the process of tuning. This is a very recent and new memory kit, memory die, so it's capable of high speeds at very low voltages. It's currently running at 125, I think. It's not a champion in anything because it's not dual ranked. It's single rank, so not very good for bandwidth. But the frequency is high. The power consumption is low. Yeah, we're currently running at 122, sorry, 122 DRM voltage. And the timings are also pretty good, like TRDL8, TRDS4, and the FEW16, of course. And currently testing refresh interval maximizer. Currently in the process of getting better to refresh interval. Yeah, I guess that is all for the video. I hope you find it interesting, and we'll update if there's any other results in the future. Yeah, ciao!